Welcome back to the unit on dividing fractions. Today's lesson is about how many groups of one number in another number. The goals of today's lesson are that you can find out how many groups there are when the amount in each group is not a whole number. And another goal is that you can use diagrams and equations, multiplication and division equations, to represent these questions about how many groups. So let's look at equal sized groups here. We've got 8 $5 bills are worth $40. Let's write a multiplication equation and a division equation to represent this. So for multiplication, I could say 8 times 5 equals 40, or I could write it the other way around, or 5 times 8 equals 40. And for division, I can write 40 divided by 5 equals 8. If I divide 40 by 5, I get 8. Or I could write 40 divided by 8 equals 5. And here's another example. There are 9/3 in 3 ones. So let's write a multiplication equation to represent this. There are 9/3, 9 times 1/3 equals 3 ones is 3. 9 times 1/3 equals 3. And a division equation could be 3 divided by 9 equals 1/3. 3 divided by 9 is 1/3. Or I could say 3 divided by 1/3 equals 9. So write a multiplication equation and division equation to represent a fraction problem represented by a diagram. So multiplication, I can write, I've got all of these fifths, I've got 5 of them, so I could say 5 times 1/5 equals 1. And for division, I could write 1 divided by 5 equals 1/5. Or I could write 1 divided by 1/5. How many 1/5s are in 1? There are 5. 1 divided by 1/5 equals 5. We can also use pattern blocks to represent these. So this hexagon here, the yellow one on the left hand side, is used to represent one whole number, and the red one would fit in like this into the hexagon. The red trapezoid, this represents 1/2. 2 of these would fit into the hexagon, and then the parallelogram here, 3 of them would fit in here like this. So you can see that that's 1/3, and 6 of these would fit in. So this is 1/6. They would fit in like this. So 6 of the triangles would fit in there. So using that, how many halves are in 4? And I've already drawn this. You've got 1, 2, 3, 4, 5, 6, 7, 8. You can see that there are 8 halves in 4. So to represent that with a multiplication equation, I could say 8 times 1/2 equals 4. Or for a division equation, how many halves are in 4? 4 divided by 1/2 equals 8. There are 8 halves in 4. How many 2/3 are there in 3? So I've got 2/3. Here's that's 2/3. So I've got 1. That's another 2/3, the second one. third one, a fourth one, and I've got half of another 2/3. So I've got 4 1/2 2/3 are in 3. So I could say 2/3 multiplied by 4 1/2, which is 9/2, equals 3. Or for division, I could say 3. How many 2/3 are in 3? 3 divided by 2/3 equals 9. 2/3, 9/2, or 4 1/2. So we can use pattern blocks, tape diagrams and equations to think about questions such as how many halves are in 6. And let's just do a tape diagram for this one. How many halves are in 6? So I've got 1, 2, 3, 4, 5, 6. And let's split them each into halves. So I've got a half, and so on. And if we count these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's a tape diagram. If we were to use pattern blocks, we would have drawn them like this. We would draw 6 of these. Oops. Four, 5, 6. So how many halves do we have? We could count them there again and get 12. Or we could do a division equation, use a division equation, and we would say 6 divided by 1/2, and we'd get 12. So to recall today's goals, you saw how you can find how many groups there are when the amount in each group is not a whole number. And you can use different types of diagrams and multiplication and division equations to represent these questions. And that's the end of today's lesson.